Hello everyone, I'm Mohammed Faris Al Jamous and alongside with my colleague Omar Mohammed Zena, we are excited to present our work on a modular command and data handling board for CubeSats. Before we dive in, I want to mention that this research idea actually sparked from our interactions with SpacePoint, and we are looking forward to collaborating with them for testing in the near future. Today, we will cover the evolution of CubeSat needs, the limitations of current design, and then Omar will walk you through our proposed heterogeneous architecture and its reliability. CubeSat missions are evolving rapidly. We are moving from simple housekeeping to high resolution imaging and onboard AI. These modern payloads generate continuous high bandwidth data streams that require real time processing. The problem is that traditional designs are monolithic. They rely on a single processor with no clear expansion path. When mission requirements increase, these designs hit a wall because they can't be easily scaled or modified. Our solution is a dual layer control system. We use an MCU for real time and an MPU for high level computation. It's built on the PC 104 standard for mechanical compliance, making it drop-in compatible with existing CubeSat stacks. I will let Omar explain how we actually connected these pieces.
Thanks, Faris. As you can see, our board integrates the STM32H743 MCU and the STM32MP157 MPU. These are linked via the Ethernet switch. This setup allows us to connect additional computing boards or nodes without redesigning the core system. And so we can connect other Ethernet switches on other boards with the Ethernet switch we have right here in order to make a distributed computing network where we can introduce devices such as FPGAs or GPUs and whatnot. We chose the STM32H743 for real-time control. It operates independently to ensure the CDHS remains functional, even if the high-level MPU fails. The MPU runs embedded Linux to handle the heavy software stacks required for complex payloads. Also, it gives the option of having a file system, which makes development easier. The Ethernet switch is the backbone for our modularity. It has 7 ports connecting our processors and leaving spare ports for future expansions such as FPGAs or GPU modules, and also other Ethernet switches which can be connected to some other computing nodes. We also use VLAN and quality of service to prioritize critical telemetry over standard data flow. We use 2 separate buses. Connector 1 is for the standard satellite system bus handling UART, SPI, and CAN subsystems for, like power and communication, which is connected to the rest of the satellite subsystems like the power and the payload systems. Connector 2 is dedicated to the high-speed Ethernet bus for intermodule computing. This separation ensures zero compromise between safety and speed. We use 2 separate buses. Connector 1 is for the standard satellite system bus handling UART, SPI, and CAN, which connects to the other systems like the power system, communication system, payload. Connector 2 is dedicated to the high-speed Ethernet bus for intermodule computing. This separation ensures zero compromises between safety and speed. To handle the harsh orbital environment, we've included FRAM for radiation-resilient data retention and NOR flash for stable program storage. We also have dedicated external watchdogs and redundant clocks to prevent system lockups. In our initial bring-up, we validated the power isolation and the high-speed system clocks. Compared to existing systems, our design offers very high modularity because it is specifically built for scalable AI and FPGA nodes via the internal Ethernet network.
Looking ahead, we are focusing on complete hardware implementation and developing FPGA expansion modules for single processing. As I mentioned earlier, this is where our relationship with SpacePoint become vital, as their expertise will help us with the radiation and reliability evaluation of these distributed nodes. In summary, we have transformed the command and data handling system from a static board into a scalable, networked platform. It strikes a balance between low power reliability and high performance scalability. We are ready for the next generation of CubeSat missions. Thank you, everyone.